Hello, everyone. We are here on day 3 at Bio 2026 in San Diego, and I'm sitting with a new friend. He wants me to call just by A, but I'm going to call him Alex. He is Dr. Alex of Curelab. He has 2 different initiatives. There's Curelab Oncology and Curelab Veterinary Medicine, or Curelab?
Yeah, we have 2 companies, sister companies, Curelab Oncology for human medicine,
Yep.
and Curelab Veterinary for pets. As you know, Homo sapiens is a great model for a dog.
I agree. Are we going to talk about transgenic animals today? Are we going to talk about that at all?
Oh, I have nothing to do with transgenic animals.
Yeah.
So you can talk to me about poetry, music, transgenic animals, and other irrelevant topics.
Or we could talk about DNA-based treatments.
We can.
Let's talk about DNA-based treatments too.
Let's make it simple.
Let's make it simple. Okay.
If you have any friends with a dog or a cat, more likely than not, their pet will not die of starvation, will not be eaten up by a predator, will not die of cold in the winter, will be vaccinated. Thus, the good news is that it will live long enough to develop cancer, limping,
all sorts of other serious diseases, yes, absolutely.
And other diseases which in wild, they would never develop. They would be eaten up or die of starvation before that.
So if they're going to live that long...
The bad news is that I have to see, and my team have to see our families for shorter hours in a week than our families deserve, because we have to work hard to mitigate those diseases and make your friends to enjoy their 4-legged family members for a few more years, okay? Never eternity, but few more years. So Curelab Veterinary is for pets. Curelab Oncology is for
the rest of us. Yes.
Yeah.
So with that, we have here the best intro I've had all week by Dr. Alex Shneider of Curelab. And you guys do focus on DNA-based treatments, correct? That is the focus of your work.
No. The focus of our work is a patient.
Yeah.
Is a
I fell into that.
Everything else is the means. If the means,
of course,
for us are DNA-based products, so I focus on the patients with DNA. But listen, I'm happily married, not with DNA products, but with my wife Elena. For 36 years, I didn't buy her any single piece of jewelry other than 2 stars of David when 2 sons were born. But I spent all this money developing this medicine and calling it naming after her, Elenogen for humans, and Elenavet for men. I'm not married to any particular class of chemicals or molecules or so. If tomorrow our research would lead us to shift from, let's say, plasmids, it's circular DNA, where a particular gene is inserted, to something else, and more likely than not, Elenogen 2.0 will not be a DNA, it will be something else, which our research led us to. That's fine. The goal, the focus, the devotion, the dedication is the patient. Everything else is just biochemistry.
I love how I fell into that. Okay, let's take this thread for a minute, okay? So your work, you followed your passion, and you indirectly discovered something. So tell me about the eureka moment that you had with your organization as you were working on your treatments, and how that eureka moment led to something different than you had originally intended.
I had a eureka moment when I met Elena. With my science, this is one of the most insidious myths which we poison our students with, these eureka moments. You wake up, you enjoy the world in the morning, brush your teeth, and then, before you go to bed, be humbled. Look at the results and remember, Mother Nature is not a restaurant. God is not your waiter. Everything you think about your experiments, your nature,
Your work.
your work, science behind it, is incomplete, partially incorrect, always have to be challenged. And what is experiment? Experiment is a dialogue with Mother Nature. It's a special language how you ask a question. But Mother Nature, she's a little bit a bitchy lady. If you ask a stupid question, she will slap you with the results, which are poorly interpretable or something. So
I can agree to that, yes.
Always
Yep.
remember, you ask a question via your experiment, and always think that the answer you receive may be loaded and may have, like with an interesting person, like with an interesting book, like with an interesting movie, interesting music, maybe a surface level, then deeper level. So it's not a eureka moment. I don't want people in my team who think in terms of moments. It's about process, it's a lifestyle, it's a philosophy. It's every day how you inhale and exhale. Look at the data and ask yourself, what else could it be? What else could it imply other than what I originally thought it could be? Then it would not be a eureka moment, it would be eureka life.
Yeah. But okay, so with all that, and I believe in the same fundamental thinking, you did have a certain directive with the science and the work you were focused on, but then it revealed something very different, this chronic inflammation that you could tackle. So I'm curious as to how that felt. Like you opened yourself up to the opportunities. Mother Nature didn't slap you in the face and said, hey, you did come up with something that could have a positive impact on something else. And by focusing on the something else, it actually has a positive impact on the whole.
Okay.
Right? Yeah?
Absolutely. So, my original hypothesis, because I came from the field of DNA vaccines.
Yes.
So my original hypothesis was predetermined by my previous life. I mean, it's natural. And I thought, okay, how could we develop the most efficient anti-cancer vaccine? What would be a cancer-associated antigen which differentiates cancer cells from non-cancer cells? And yet, cancer cells would not be able to stop producing this target. Because it's very easy to make a product targeted therapy like a vaccine, which would seem effective for 5 seconds, and then a cancer cells would stop producing the target. And I said, okay, for certain reasons, maybe we should not discuss them here, otherwise your viewers would fall asleep. But I decided, let's focus on P62. So we took this circular DNA, we put there a gene P62, we injected it first to animals, mice, rats, then dogs, and later we went to humans with great success. And the question to me was, am I lucky or smart? Why? Because we run into an observation which was easy to ignore, but impossible to explain with my original hypothesis. We observed, serendipitously so, that we downregulate the entire spectrum of
inflammation,
cytokines associated with chronic inflammation. Okay, and they're called interleukins. And then we upregulate the broad spectrum of anti-inflammatory molecules. A smart person would just walk away, because if it is not within your original hypothesis,
Yeah, then why is it
and
relevant?
the curse of our time
Yeah.
we shall redeem ourselves from, is so-called hypothesis-driven, mechanism-driven drug discovery. Okay, if this is not within your original mechanistic idea, you better ignore it. Otherwise, they would accuse you of losing focus and all,
Of course, yeah.
all other curses. But it was not a eureka moment. It was a eureka process. We start asking ourselves, maybe we were more lucky than smart. Maybe there is something else which we couldn't think about. Okay, so we discovered, we observed, we reported that our product takes under control chronic inflammation. Then it led to additional applications. And then it was a Eureka level 2.0. Does our product work directly or indirectly? And it turns out that it does both. So it's a fun life.
It is a fun life. And I think it is remarkable, the work that you've done and how it's having an impact. So I'm curious, from your standpoint, do you think traditional pharma will be slow to embrace this?
Take out the word "this," because are you satisfied how traditional pharma embraces anything? Because it's a general question. If a traditional pharma would be slow to embrace just Curelab, you live in an alternative reality.
Yeah.
Go to any cancer hospital and non-cancer hospital and ask yourself, does traditional pharma do a good job embracing anything?
Yeah.
Insidious nature of humanity is that during the time of war, during the time of crisis, who is the most efficient? Actually, traditionally, there are two the most efficient industries embracing innovation.
Yeah.
First is porn.
Yeah.
Porn, they embraced video, photo in the beginning of 20th or 19th. Well, then
E-commerce.
internet.
Right.
Second
Yep.
is military. During the time of crisis. And unfortunately, it may or may not be the case with contemporary Western bureaucracy, even within military. That's why my heart is crying when I think how we succumb our veterans with chronic pain after Vietnam War and other, and debilitating them with, for example, opioid drugs, so they could not reintegrate as productive members of the society. So to me, it's very important that, for example, we learned that we take under control chronic inflammation. We started with cancer. What else is chronic inflammation? Chronic pain, neuroinflammation.
Yeah.
Okay? We published a paper in dogs. Now we will be looking to collaborate with other branches of medical establishment, not only for cancer, but overall, unfortunately, any big system, Brezhnev's USSR or big pharma, doesn't matter. Any big system, by definition, has big inertia. This is almost like laws of physics.
Oh, it is like the laws of physics. Okay. Your focus right now, today, I feel like I have to be careful about how I ask these questions.
Don't be. Let's smile. You know, the biggest mistakes people make when they have serious faces. They start wars with serious faces. Let's make mistakes together.
Okay, we'll make mistakes together. Okay. Today, you're focused on plasmid DNA, and I'm curious, it's much more cost-effective than biologics, right? Would you agree on that front? It can be.
I didn't understand your question.
When you're manufacturing plasmid DNA...
Okay, let's take a step back.
Yeah.
And let's say there are three big kingdoms of drugs. First, let's call them chemicals. They are products of chemical synthesis.
Yes.
Second is biologics. You, for example, cultivate bacterial or yeast or mammalian cells. They produce something, a protein or an antibody or a plasmid, and you purify that. And third, which unfortunately modern civilization is turning our blind eye to, is botanicals. So you harvest natural plants. So within biologics, we work within biologics.
Yes.
Okay. There are different types of products, antibodies or proteins, like proteins, insulin, for example. Antibodies are used a lot for different, especially in cancer. We work with plasmids, which are circular DNA encoding certain genes. Within biologics, they are the most economically feasible, okay? Because let's face it, the world is divided for golden billion and for the rest of the humanity. And the divide is huge, and access to modern advancements in medicine is huge. And let's say in America, people can afford not to think about cost of goods.
Yeah.
This is how we bankrupt the richest country in history. But anyways, plasmids may be the most economically feasible.
And that's what I'm trying to say. So if it is the most economically feasible, what do you think about its impact on developing countries? Do you think that this is the kind of treatment that would allow for better patient access in developing regions around the world?
It will depend on their governments, and it will depend on their...
well, let's say ideally.
I mean, listen, frozen plasmids can maintain their therapeutic or preventive potency for years and years. And they're much cheaper and easier. And of course, if you were to select a particular class of products for less affluent part of the world, unambiguously, from any technological, biochemical, biotech point of view, of course it would be plasmids. But once again, I'm not a soccer fan rooting for one team versus another team. Like, I enjoy FIFA in Boston just for the festive of the moment.
Very timely right now because the World Cup is happening.
Festive of the moment. But I'm naturally not a fan of a particular team, especially within our profession. Yes, plasmids do have unambiguous biotech advantages from many standpoints, production, economics, but also what can be done within your body fundamentally, because antibodies is mostly good for freely floating pathogens or what is sitting on the surface, like Herceptin binds HER2 on the surface of cancer. But majority of stuff, when it is going inside the cell, antibodies may or may not be. Forget about the price, the very fundamental immunological taboos, and
it's not as effective. You're saying?
I mean,
it may not be as effective.
Listen, go to Home Depot. You have many different tools. every tool has its application. So if I am developing better crunches, I should not be bad-mouthing those who produce hammers. So it's not crunches versus hammers. But still, unfortunately, there is the first step. Antibodies do bind a particular antigen on the surface of a cancer cell. That's great. Then the second step, let's have the same antibody. It's like letter Y. One part will bind one antigen, another will bind another. Good. Yeah, a lot of money is invested in it. It will be only marginal effect. It will, you have a car with a little bit better transmission. It's good for a customer, but then it would come airplanes, then it would come satellites, okay? So it all depends on your optics. What I think is the next level is an entire reprogramming. I mean, it's very hard to get cancer. You, I, her, we all have many pre-cancer cells, but when homeostasis in our body is prohibitive to these pre-cancer cells to developing tumors, we're healthy, we annoy our spouses, we try to minimize our taxes, we occupy too much space in the office. I mean, we live full life, okay? However, when your immunity loses proper programming, the secondary, I mean, I'm not talking about Chernobyl or something like this, but normally cancer is secondary. So I think the paradigm shift which shall happen is having a medicine which doesn't patch a particular hole, which fixes the root cause. And what I'm happy about, happy doesn't mean proud, because I have nothing to be proud about. It was not my oracle, it's just we happened to run into this serendipitous discovery, So we were more lucky than smart. But what I'm happy about, that now we see that our product, which was originally invented just to patch the hole, turned out to be a systemic reprogramming tool which helps the body to regain its proper program. Thus, anti-cancer effect and many other therapeutic effects will be secondary to this. So it's a paradigm shift, not just a better patch for yet another hole.
I absolutely agree, and I love that you're doing this. So, okay, I'm going to get to one last question, okay?
Just a second. Last question means then he will take his gun and will shoot me?
No, my gosh. Oh my gosh.
Because maybe I should have my last wish before his last question.
Oh my God.
Also, very rarely the actual last question.
How are we on time?
We're at 20.
Okay. All right. So we're playing biological chess together tonight. I think that's what's happening. Here's what I wanted to ask, though. You are absolutely passionate, I can tell, about the work that you do and your family and your wife and all the things that you're working on right now. I'm wondering, from your perspective right now, with all the things that are going on in the life sciences, what are you most excited about?
I'm most excited about the moment I have right now. At this particular second, I'm the most excited to talk to your audience through talking to you. Then I will step out and I will be the most excited to get my phone and to call to my colleagues and to see what the latest results are.
Yeah, yeah.
Then I will be the most excited to have my next meeting with C-level guys from pharmaceutical companies. During the dinner, I will be the most excited to share thoughts with representatives of different governments who we may partner with, changing lives of millions of people who I never met. And they will never know that it was my team and I.
I hope they do get to know who you are.
No, it's not my goal. Then I will be the most excited to call my mother and to learn that she is healthy. I'm the most excited about here and now.
I love that answer. I love that answer. I think that the work that you're doing is profound, so I do hope it has a great human impact on all sorts of people who are ailing from certain diseases and can benefit from all of this. And I hope you continue to follow your passion, because I think it's going to do amazing things for everyone. And congratulations on that. It's amazing.
We're just at the very beginning of the road. I don't want to sound any bigger than I actually am. Everything is still extremely fragile. A small, passionate or whatever, talented or whatever, biotech company cannot bring it to patients alone. It takes a village.
It takes a massive village.
It takes a village
Yeah.
to raise a child. It takes an environment, governmental, pharmaceutical, investors, regulators, lawyers,
Risk takers.
ass kickers, whatever. It takes an environment. So, if this interview would sound celebratory, I wish it didn't happen. If this interview would sound focusing on how fragile this thing is at the most encouraging and promising stage where it is, then and only then it would not be a lie.
I can appreciate that. That's good. These are good sentiments for the industry as a whole. We wish that none of us have to do the things that we do. But, you know, as you said earlier, we try different things. Mother Nature can either slap us in the face or give us a high five. Yeah? Okay. No, we're going to do one of these shakings today for you. No, it's been a pleasure to meet you tonight or today here at Bio 2026. And I do hope you have a great show. I really do. It's been a pleasure meeting you. And I am looking forward to watching how your science does evolve and how it does inspire the world. So here, check him out online. It's Alex Shneider, and you'll find him on LinkedIn as well. And thank you for joining us at Bio 2026.